Welcome to today's session, Create a Unified Data Platform for Tomorrow. My name is Axel Meyer and I'm joined by my colleague Santran. We're both with SAP and we're happy to walk you through the session. I'd like to walk you through a digital marketing line of business scenario in the context of SAP Data Warehouse Cloud. The digital marketing team is demanding a real-time reporting for campaign optimization and stakeholder reporting. In this context, it's required to take fast decision on the marketing metrics by connecting and accessing multiple data sources into a single store view. The marketing metrics data are live in different systems where we also need to have some data mapping provided to the model. We also need to provide the capability to further extend the model by adding additional source information or connecting to additional data sources, but providing a consistent and stable view to the end user. So at the very end, the stakeholder required information how their spend is divided and which campaign tactics are successful.
Let me walk you through the building blocks of SAP Data Warehouse Cloud. SAP Data Warehouse Cloud is integrated with SAP Analytics Cloud. The Data Warehouse Cloud Workbench provides the editors and UI to model and configure the data warehousing application. There are 5 major building blocks available with SAP Data Warehouse Cloud. First, the source system connection. We have different interfaces we're able to connect to, like open API environments, local CSV or file upload, ability to integrate and connect with SAP Cloud and on-premises systems, also adding the non-SAP Cloud and on-premises systems, and we're also open for third-party ELT or data cloud provider in an open fashion. The next building block is about the data sources. Within the data source building block, we'll describe the data source artifacts and also their provisioning, like virtual tables for federated access to one or many of the source systems, local tables for replicated or loaded data if you want to have some data replicated and persisted within Data Warehouse Cloud instead of getting a federated access to the remote systems, virtual views like virtual HANA views. We also provide the capability for data wrangling inside Data Warehouse Cloud and also the connection management, which also includes the data space concept. On the semantic layer, we're providing the capability of virtual objects which are decoupled from the data source layer. So we're able to provide a semantic environment which can be decoupled from the data source layer, which also enables a nice way for integration with additional data sources once you establish a stable semantic layer. The semantic layer provides the model capabilities of connecting the business semantic artifacts like KPIs, dimension, facts, hierarchies. It will result into a semantic graph to encapsulate the well-defined business context and relationships by focusing on reusability and standardization. Again, the semantic layer provides a separated modeling environment, like separated from the data source layer, and the semantic environment integrates nicely with the data space concept, which is of high importance within our strategy of SAP Data Warehouse Cloud. Next to the semantic block, we'll provide the capability of a business catalog environment, where all the dictionary artifacts are available in the context of Data Warehouse Cloud. We'll provide search functions like sorting, filtering. Of course, it also includes documentation and a business certified definition. We'll provide data lineage and impact analysis functionality, including versioning and artifact comparison. Last but not least, the visualization part. As we're integrated with SAP Analytics Cloud, of course, this is a nice way to get the visualization part created, but we're also open on an API layer for external visualization tools.
Let me walk you through the first step to build the digital marketing model. We're going to leverage Data Warehouse Cloud to generate the federated access to the source system data tables, automatically generate the according semantics, and build a semantic model by connecting the individual semantic objects to become a virtual model. Once we're done with the semantic model, we create a story within SAP Analytics Cloud to consume the model data and visualize the according information to fulfill the needs of the digital marketing stakeholders. Jane is a modeler within the digital marketing LOB team, and she got the task to build the digital marketing model. As Jane is aware that there are some marketing systems available within the company, Jane reached out to Tom to ask for access to the C4 marketing system and the C4 commerce system. Tom provides the access to the C4 marketing system and the C4 commerce system to let Jane log on to Data Warehouse Cloud to connect and access the relevant C4 marketing tables. So Jane logs onto the system, and as she got access to the marketing system and the commerce system within the data source environment of Data Warehouse in Cloud, she simply connects to the existing master data tables and reverse engineer the structures to become a virtual table within the data source environment, including the full connection information, so that we got the information within the data sources that we have, like the marketing area data accessible, the device type accessible, and also the interaction status accessible. Jane is going to flag those tables to become a dimension type of data source. It's important to mention that we haven't replicated anything. We just provided the access to the C4 marketing master data tables, including a virtual table to be leveraged later on within the Data Warehouse Cloud semantic models. Data Warehouse Cloud is smart enough to also generate on the semantic layer a virtual objects according to the dimension objects, which would be interaction status as a virtual object, which also provides the interaction and connectivity to the dimension virtual table interaction status. And the same is true for the marketing area and also the device type. So we're using Data Warehouse Cloud to reverse engineer the structures we got within the C4 marketing system. We're generating the virtual access to the C4 marketing data and structures. We created a virtual table within the data source environments and automatically also generated the virtual semantic objects connected to the data sources. So we're done with the dimension. Next step would be that Jane connects also to the campaign information, which will be also generated as a virtual table as a starting point. And Jane will flag this information to become fact of table of type data source. Data Warehouse Cloud automatically generates a semantic virtual object called campaign, which is also connected to the data source virtual campaign table. Jane continues to run the same activity for the interaction, which will also generate a semantic object interaction. And from the second system, the C4 commerce system, she reverse engineers the data for the leads table. It will also end up in a virtual table on the data source layer and a leads semantic object within the semantics block. Jane got all the information available within the semantic layer to generate a model relevant for the first step of the digital marketing model. Next step would be to leverage the semantic modeling capabilities and provide a real model by connecting the dimensions and the facts to become a model. So Jane logs on to the modeling environment of Data Warehouse Cloud and connects the different dimensions with the fact objects of the semantics. Once the linkage has been completed, a complete model has been created, which is separate to the data sources. The reason why we're separating the data sources from the semantics is to provide the flexibility to also adjust connection to another set of campaigns as an example, or will also provide the ability to exchange the data source layer by a new data source layer by keeping the semantic model stable, which will help to further proceed on the modeling capabilities. As we're done with the semantic modeling right now, we're almost ready to generate the story using SAP Analytics Cloud, which is called campaign analysis. Within the story, we're connecting to the semantic model and get access to all the information based on the semantic model, which later on connects to the data sources where the data will be retrieved from the remote systems. So we're providing an agile way to reverse engineer existing data and structures into the data source layer. We're automatically generating the according semantic objects. And we're providing a modeling environment to flexibly connect the virtual objects within the semantic layer to become a semantic model. And you can leverage the complete semantic model by generating a story as an example with an SAP Analytics Cloud or an API supporting to connect to the semantic model to consume all the information and visualize the application data to the end user. We're logged on to the workbench of Data Warehouse Cloud connected to the C4HANA space. First step would be to reverse engineer the access to the marketing area dimension table, which is available within the C4 marketing system. Tom provided the access to the remote systems, and now we're able to browse and reverse engineer the structures within the C4 marketing systems. So we identified the marketing area table. We'll drag and drop the table into the modeling environment. We're mapping the marketing area to an output node, provide an identifier name, and also specify the type of this data view, which is dimension in this case. Once we're done, we'll close the properties and save the configuration. Behind the scene, the full access to the remote system is being generated, and we're able to deploy the configuration to the system. As a next step, we'd like to illustrate how to reverse engineer the campaign information from the source systems. So we're browsing for the campaign table data, which has been identified within the C4 marketing system. We'll identify the table, drag and drop the table to the modeling environment, and the data warehousing workbench automatically creates the remote connection to the C4 marketing system, including creating an output node as the semantic object. Within the properties section, you can provide an identifier to this data view and specify the type, which is fact in this case. Once you switch to type fact, you are able to provide and let the system automatically generate the type of the different columns so that you'll end up within a set of attributes and a set of measures according to the data source. You also have the ability to specify a given aggregation and semantic type, but we leave it as default for this recording. Once we're done, you need to save the model and run the deployment to the system. Once the deployment completed successfully, we'll provide you the ability to get a preview on the data. So a data preview would be immediately available once the deployment completed successfully to get you an idea on how the data looks like. In step 3, we'll focus on creating the semantic model by reusing the previous generated semantic objects as the output node from the data view. Here we're going to focus to create a model based on the campaign fact information by adding additional dimensions to the model. On the left, you can see the different views which have been deployed from the previous steps, and you can go ahead and pick and choose the according dimensions you want to get added to the dimension fact table and provide the association properties to get the campaign connected to the according dimension information. You can develop the model based on your requirements. You can flexibly adjust the mapping and assign additional dimensions to the model. Once we're done with the modeling, we're going to save the model and deploy it to the system. Next step would be to create a story which connects to the previously generated model. Within the SAC Story Builder, you're able to select the previously saved and deployed model, and in this case, we're connecting to the fact campaign model. We're providing you the ability to reuse all the capabilities from the SAC Story Designer by connecting to the previously created semantic model. In this case, we're interested on the number of clicks per campaign name, so we're able to visualize without any previous steps to optimize the access. We're able to visualize all the information available by the semantic model. We can use all the graphical and visualization components available within the SAC Story Builder. Once we're done, we're going to save the story to the system, specify a title, and we're able to reuse this information at a later point in time. In step 2 of building the digital marketing model, Jane identifies that additional information is required to be loaded to the system, which is not available in any of the connected systems so far. So it's required to add some local CSV file data to the model. In addition to that one, we need to create the semantics to connect to the data sources and also enhance the already existing semantic model to keep the story stable without any impact to the modifications. So it's another example on how the differentiation and separation between the semantics and the data sources will help us to provide the LOB users a flexible way to enhance the semantic models without any impact to the already existing story. And we have the flexibility to adjust the data sources as we request without impacting the semantic model. So let's get started. Jane requires to add a local CSV file to the scenario. So she creates a local CSV file called hclasses and uses Data Warehouse Cloud to create a data source to connect to the CSV file, reverse engineer the structure, and build a persistent table, including the data load capabilities to load the CSV file into a persistent table within the data source environment of Data Warehouse Cloud. Once the table has been created, Data Warehouse Cloud automatically generates the according semantic object called hclass, which also has the connection to the persistent tables. Once semantic has been created, next step would be to connect the semantics H class to the already existing semantic model. Jane uses the Data Warehouse Cloud capabilities of semantic modeling and connects the campaign to the H class. So Jane simply enhanced the virtual model by adding the H class, and due to the ability of Data Warehouse Cloud, the structure available for the interface on the story level got enhanced, so the existing campaign analysis story will remain stable. No further adjustment is required, but the additional information on the H classes becomes available instantly. So a new visualization component can be created, or the existing visualization components can be enhanced by the added information based on the H class information. So we're providing the ability to flexibly enhance the semantic model without impacting the already created story. So the story remains stable, which is an important factor for any investments being made to the visualization environment, and there's no impact to the semantic layer at all. In the next step, we need to add a local CSV file to the model, as the relevant information is not available within any of the connected system. Jane used the dialog to upload the CSV file. She specifies the table name and also the description, where the workbench by itself would analyze the CSV structure and create a local table to the marketing system, including the data load to this persisted table. Once we enter the workbench modeling environment, we're able to search for the H-class table, which has been created within the previous upload step. Once you get the table name, you can bring that to the modeling environment, and we'll create a data view, including the output node, which would be the representative semantic object once we deployed it to the system. You can provide an identifier name and also the type, and check the according attributes. Once we're done, we'll save the configuration and deploy it also to the system. A new semantic object H-class is being generated. A data preview capability is provided with any output node. So this is a nice way to validate on how the data is being represented. As we're done with the H-class dimension right now, next step would be to enhance the previously created semantic model called FactCampaign. So it's required to add the H-class dimension to the model, and you're able to identify the H-class semantic object within the deployed views. So we're using the modeling environment to enhance the FactCampaign semantic model by selecting the according column from the campaign object and adding the linkage to the H-class. Once the model is saved and deployed to the system, we can switch to the existing story within SAC Analytics Cloud, and we're able to either enhance one of the previously created views or create a new object to visualize the new added H-class information. As you can see, the other graphics remain stable without any impact. Of course, you will be able to further adjust it and also add the H information to the previously created graphics. In step 3 of building and enhancing the digital marketing model, Jane became aware that campaigns have been released last week on a new channel, which is not part of the C4 marketing channel analysis today. Jay is being asked to integrate the additional campaign data using a cloud data provider into the existing digital marketing model. It's relevant that the existing semantic model and the story keep stable to the end users, as this would only reflect an enhancement on the data sources to the existing models. Jane is using Data Warehouse Cloud to connect to a cloud data provider and reverse engineer the structure, including creating a persistent table focusing on campaign information of type fact. As we have an existing campaign virtual table already connected to a semantic object campaign, which is part of the overall semantic model, we need to make sure that the existing semantic model remains stable and also the story keeps intact by adding an additional data source to the environment. As we got the campaign information already loaded as a virtual table into the data source layer and new campaign information persisted right now, we're using Data Warehouse Cloud to integrate the data using a union or join based on how you want to integrate the data. And once we're integrating the data using a union or join, we're able to automatically connect the existing campaign semantic object to the integrated data set of the virtual table campaign pointing to the C4 marketing table and also to the new loaded third-party campaign table. Again, the model, semantic model remains unchanged as we are automatically connecting to the already existing campaign semantic object, and additional data becomes available immediately as the story keeps stable without any impact to the end user. Once the new channel campaigns have got integrated into the C4 marketing environment, of course, it's possible to adjust the mapping and remove the union or the join later on to get rid of this fact table later on as the additional campaigns will be integrated pretty soon into the C4 marketing environment. So we're providing the ability to add additional data sources, but we also provide you the ability to further adjust and remove, like optimize the number of data sources to the overall system without impacting the semantic model and the connected stories. Jane is being asked to add external campaign data provided by a cloud data provider to the system. To do so, we need to connect the external system to the C4HANA space, the same space we used within the previous recordings. Within the edit dialog, we have some information on the general settings like compute node and storage capacity assigned to the space. And within the remote connection dialog, we're able to select the Adverity system, which is a partner of us, to be connected to the C4HANA space. Once we're done, we're saving the configuration and switching back to the modeling environment. We're reusing the existing fact campaign semantic object and selecting the data view we previously created already, which has the campaign and the output node. Now we're interested to add the campaign information from the Adverity system to the existing data flow. We're selecting the table from the Adverity system and adding, like union, the information to the existing campaign flow. So now we're adding the Adverity campaign information to the existing flow by mapping the original campaign to the union properties and also adding the Adverity information now where we need to manage the mapping within the union node of this flow. Once we're done here, the output node gets updated We can reuse the output node as the previously configured semantic object within our semantic model without any impact to the existing model we previously created. Also, the story doesn't get any impact because now we are reusing the previously created output node within our existing model. Once we're done here, we'll save and deploy the adjusted flow to the system. Let's switch to the existing story. We'll log on, we simply refresh, and now, as you can see on the left, like the number of clicks, the number of impressions gets updated, and also within the previously created graphics, the new data, like in this case, the global information, and also the number of clicks by our campaign name, like a new campaign has been created, has been added to the system. In step 4 of building and adjusting the digital marketing model, we're going to focus on the transform of the federated access into local tables by keeping the semantic model and the story stable without any impact to the end user. In this case, Jane recognized that many users are leveraging the system, which triggers the need to optimize the overall performance of the system. Jane connects with Peter from the IT department to optimize the access to the campaign interactions and the lead data. As we speak, this is still based on a virtual table like a federated access to the remote systems. Peter logs on to Data Warehouse Cloud and automatically transforms the remote access, like the federated access, into a local table access using Data Warehouse Cloud. So we provide options to transform the virtual access into a local table and also add the data loading or replication capabilities to the system so that we're able to add data warehouse services by persisting the data into the data source layer without any impact to the separated semantic model, as we are updating the connection from the campaign semantic object to the persisted table to locally access the data. Peter continues to optimize the access for the interactions and also for the leads table by adding automatically data load or data replication capabilities to the system. Again, the semantic model remains unchanged and stable, including the story, so there's no impact to the end user at all, where the positive impact should be that the performance got optimized as we now keep the data local to the system without any network to connect to the remote systems table and data. So it's an important task also not only to build a model in an agile way, but we're also capable to provide the ability to transform a federated access into a local table environment, including data loading or data replication capabilities. This should help to optimize the access, and we're also providing additional data warehouse services to the persisted tables. Again, it's important to mention the semantic model and the story remain stable without any impact based on the adjustments within the data source layer.